The final speaker of the session is Stephan Sahm. Are you here? Oh, great. Okay. Yeah, we're just gonna move right on. So Stephan has his own Julia consultancy, and we're gonna get to peek into his personal toolkit and look at some of the utilities that he finds convenient.
Thank you very much for the introduction. So, there we go. I want to show you 3 little tools of mine. They're really tiny, and 2 of them are pretty old by now already, but it seems like I'm almost the only one using it, and I want to change that. So yeah, let's see. Maybe the one or the other fits also into your toolbox. So I'm Stephan. We have full screen. Yeah, looks good. Stephan Sahm, Jolan.io. You can check it out. There's also a recent product launch at cloud.jolan.io. Yeah, I'm welcoming any testers. Let's start right away. So we have 3 packages: SimpleMatch, NotMacro, and ProxyInterfaces. So first one is SimpleMatch. That looks a bit tiny. That's okay. Yeah, I won't do this the whole time, but at least kind of for the beginning, I have some Zoom specialty. This one was kind of started to get something like Match, and we've seen it just a couple of presentations ago. There is ML style, and there are other packages which give you a match function, where you can kind of somehow deconstruct things. And they have been just too complicated for me in the beginning. I wanted to have something very, very simple. Yeah, so they are all fancy and great, but it just looked too much for my mental life, and I wanted to have something simple. And the simple thing which is there in Julia, which you know by heart, are these functions. They do already kind of some kind of matching, yeah, this dispatch. And yeah, I like them, I use them a lot, and this would be kind of one style how you can use this for matching, yeah. For like you just define your inner function, and yeah, it's kind of okay, but you have kind of this reversed order, first defining the function and then calling it to dispatch on it, and you also need to come up with a nice name. So yeah, these are kind of the 2 things which SimpleMatch is going to solve for you, and this is it, here it comes. So if you make using SimpleMatch, you get access to this little match macro, which is really just rewriting this code to get you yeah, inner function with an anonymous name. And yeah, and the syntax I've used here is this do syntax. This allows like for normal function call. Yeah, in this match parentheses, you really put whatever arguments you want. You can have splashes, you can keyword arguments and all the like, and it's really just forwarded to this inner function. And using this do style, it's super intuitive that this is now really an anonymous inner function. So this is why I really like this style a lot. But I want to have kind of care about the function names. And you also have this order, like typical for a matching style. You first define what you want to match, and then you define the cases. And yeah, so I hope you passed this example here. So we are inputting a value type, yeah. So a value. So and we can kind of dispatch on it. And this is kind of an expression example. So we get the head and use Julia's dispatch to get all these cases. But you can use it for arbitrary objects. This is really just function syntax. Okay, so super tiny package. Maybe it's also something for you. Check it out. This is SimpleMatch. Okay, going to my next little one is NotMacro. I have to admit I'm not using this a lot, but still for me it felt like, I want to have this. So little disclaimer, of course, I know. Julia is not Python, and that's good so. And I myself came from the Python world, and I love Julia. For a little extra note, there's a really long discussion on adding and, or, and also not, yeah. And this is clearly answered with a no, yeah. So there won't be these things as Julia syntax. So you stick to these little and or yeah, how to spell them. This is fixed, but not you can get, and this is because not is just kind of at the very base. It's lowest binding, so we can write a macro which does this, and this is it. So here's NotMacro, and yeah, you just use it like not, but put an at in front. And this works because we can restructure the code so that it actually follows the strict binding. So usually every macro gets all the stuff in it which follows after it. This is of course not the semantics here, but the implementation of the not macro now follows the standard semantics. I hope you get what I mean. So if we macro expand it, you really see that we just have our normal negation in front of everything. But the semantics of the macro, of course, they work differently. You get the entire thing as the first part, and now we need to restructure this. And this is why there's a package for it, So it's not super straightforward to write it on your own. So you need to do some checks that this is really kind of well done, and hence there's this little package. Okay, so if you like to have not instead of exclamation mark, that's for you. Thank you. Last one, proxy interfaces. And this, I hope, is really going to be used much more, or something similar around this. So the thing is that we have all these nice, we have the separation between types and functions in Julia. And this is really awesome, so we can kind of build whatever we want. And one thing is like a proxy. So this is a little example. Now this is a type which adds something on top on the normal dictionary. But I actually don't want to re-implement the normal dictionary, so I proxy just everything else to this dictionary, which I store inside my proxy type. So I have my Dict over here. And and now I need to re-implement every single Dict function. So that gets tedious, and this is a lot of work. It actually may be that as of now, there are also some other packages out there, but I haven't found them easily. So this is mine, already a bit older, to just have a nice general layer which simplifies this for you, where we can kind of keep a couple of these standard interfaces. So how does it work? You use proxy interfaces and you specify a mapping for the type and you specify a mapping for the value. So these two mappings are needed then, and then everything can be kind of automatically constructed for you with the respective macro then. So this would be the way for our little example. And yep, that works. So we get then access to indexing and other dictionary stuff. So it's really 3 lines usually. And so one example, that's a default dict, just overwriting the get index to have a default value, and getting all the rest kind of from the struct now dict mutable to get also the mutable stuff. I intentionally made them distinctive, so the normal one is not without the mutable stuff. And now, you get this, and it works, and of course your extra definition is taken up because it's defined afterwards. Okay, so this is the overview of stuff which is implemented. Not too much, but still very useful for me, and hopefully for you too. So we have the Dict, the array, indexing still separate, and iterator. These are kind of the standard interfaces you also find in the Julia documentation. And I'm very happy to add others. Pull requests welcome. Also, if you have it's kind of common to miss up some function because they are spread all over. So if some Dict or array function is missing, it's super easy to add them up, even within minor version changes. Okay, last one. There's also another famous macro which I put into this package as well. There's this forward macro. It was here and there recursing, and this is now also one place where it lives. So it's just a flexible forwarding a specific function to a subfield. But this is then by the generic Dict or array macro. There's no longer needed. Okay, so this was proxy interfaces. And so SimpleMatch, NotMacro, proxy interfaces. I hope some of this also fits into your toolbox. I would welcome some stars. I would welcome some code commits, anything. And last note, check out cloudjolin.io. That's kind of my work for this year. Yeah, this is really awesome Pluto deployment, maybe also for you. Thank you very much.
All right, thank you, Stephan. Yeah, that's pretty cool. But if you know how macro parsing works, then not macro is mildly cursed. I just have to say, if you.
Do we have time?
I guess so. I guess it works. Any questions?
So if I say A ampersand at not B or pipe C, doesn't the not eat up everything after the ampersand? And so it seems like it would be impossible to properly parse that.
Yeah, the question is, does the not macro eat up everything after it? And yes, it does, and that's what makes it tricky.
Yes. Yeah. Thank you. Yeah, this is why there's this page. So yeah, so you need to restructure everything so that it really is at the first place. Yeah.
All right. Thank you, everyone. That is the end of the session.